So this video is intended as a revision review, and I'm going to try and do the whole of Year 1 differentiation in as few minutes as possible. If you are looking for a video to learn differentiation, this isn't the one for you. You can find plenty of videos on my YouTube channel or the college website or my external website. Follow the relevant links, but this is a review, so let's get cracking. The basics of differentiation then. For an expression, ax to the power of n there, where a is a coefficient out the front of a number, when we differentiate this, we will get an x to the power of n minus 1, so the power reduces. We can differentiate when expressions are in terms of indices. So if we were asked to differentiate 1 over x squared plus the square root of x, we would first convert that into index expressions, so x to the power of minus 2 and x to the power of a half. So knowing your indices is a really important skill. Differentiation finds you an expression that describes the gradient for a given point or any general point on a curve or a line, which means we can use this to find tangents and normals. Don't forget, tangents and normals, they're straight lines. Your tangent works with the same gradient at a point, and it would help if it actually touched the curve there, wouldn't it? So there's your tangent at a point, and your normal runs perpendicular to that, but they're straight lines. That means they have the equation of a straight line, so y minus y1 equals m x minus x1, and m should be a number that you have found from your differentiation, but it should be a number in there. So when we differentiate, like I said, we would get the gradient function, so that would tell you what the gradient was when you substituted in an x value, and so we can find the gradient at a particular point by taking what we found as our differentiation and substituting in a known x value. That x value then would also go into our equation as x1, and then we could substitute that x value back into the original equation to find our y value for y1. That would be for a tangent. For the normal, our gradient that we find by taking the derivative and substituting our x value, so we'll call that m, needs to be turned into the negative reciprocal gradient. So for the normal, you want minus 1 over m going into the gradient part of that straight line. Differentiation is also really useful for finding stationary points. We know that on a curve, the points where the function turns have a gradient of 0, and these are our stationary points. They could be maximums or minimums, and one of the things we need to do is to classify them. So to find the location, i.e. the x value that corresponds to one of these stationary points, we would set dy by dx equal to 0. That's to find them. To classify them, so that's to sort them out into whether they are maximums or minimums or points of inflection, we need to look at the second derivative, so differentiate again, which is the rate of change of the gradient. So how is the gradient changing over time? If that is a positive number, we have a minimum, and if that is a negative number, we have a maximum. Well, that might not be a number yet, so that will be the second derivative at our known location. So these points, whatever we found as our solutions originally. So this is second derivative, substitute in a number. It's not a difficult process, but it does require some rehearsing so that you don't miss out steps. And that's it. There's your overview.